Okay. Okay. All right. Thank you. So please look at question 1. Thank you. All right, guys. Can you please do question 1, please? I'll give you a few minutes to do question 1, and then I'll show you how to do it. Thank you, guys. Hello, James. Welcome, James. So if you're just joining us, we are going through sheet number 9, example sheet 9, question 1. So I'll give you a few minutes and see if you can do question 1 on sheet 9. All right. Hello, James. You okay?
Yeah, you're right.
Good. We are going through question 1 on example sheet 9 at the moment.
Yeah.
So please take a few minutes and see if you can do it.
Power bank.
All right, guys, let me show you. If you haven't done it already, let me show you how to do it. How to do question 1 from sheet 1. Okay. Okay, guys. So hope you can see what I'm writing. Just give me a sec. So where am I? Here we are. Okay. Okay. So this is question 1. We have a sample of 81 data points, and the sample mean is equal to 74.6, and the sample standard deviation is 11.3, right? And we are looking for a 90. What's it? Is it 95% or 90? I'm trying to say. We are looking for a 90% confidence interval, which means that 100 times 1 minus alpha is equal to 90, right? Which implies that alpha must be 0.1. All right. Okay, guys. So in this question, we want to find a confidence interval for the mean. And since the population variance is not known, what we are given is a sample standard deviation and not the population. The formula that you need to use is this one. I hope you remember this from the lectures I did some time ago. Do you remember this, guys, or no? This is the formula for the confidence interval when the population variance is not known, right? You will see this in the printed notes and also in my handwritten notes from before the lockdown, before the Easter break. Okay, so you should work this out. X bar is 74.6 plus or minus t n minus 1 is 80. 1 minus alpha by 2 is 0.95. S is 11.3, and n is 81, so square root of 81. Okay, so this is now this value, the percentile of the t-distribution, you can read that from the, you can read it from the table. If you read it from the table, you will get guys, if you have any question, you can use the microphone, or you can use the chat box. There's a chat box you can write on for any questions you have, right? And so this will become 74.6 plus or minus. This value here you can read from the t table, which will be 1.664 multiplied by 11.3 divided by the square root of 81, which is 9. Okay, so this is the answer for question 1. Of course, if you have a calculator, you can. If you have a calculator, you can work this out what it is. Okay. Any questions, guys? Anything you like to ask me on question 1? Hello? Hello, guys. Are you okay with this answer or no? Any questions? Please use your microphone or use the chat box. Okay. Okay. Now, can we go to question 2, please? Now, question 2. So I'll give you once again. I will give you a few minutes to see if you can do question 2 by yourself. So can you? Okay. Let me show you where the question is. So it's question 2 is it's over here. Sorry. Share. Okay, here we are. So I hope you can read question 2. You have a sample of 30 data points, and you are given their sum equal to 1568.45, and you are also given the sum of the squares equal to 83006.73. The question is to find a confidence interval for mu when sigma squared is known, and for mu when sigma squared is unknown. Okay. Sorry, for mu and sigma squared when sigma squared is unknown. Okay, guys, can you take a few minutes and see if you can do question 2? You guys okay? If you have any questions you have, please use the chat box, okay? For any questions you have. All right, good. If you haven't done it, let me show you. Let me show you how to do question 2, okay? All right, so question 2, we have a sample of 30 data points, right? And we are told that the sum of the 30 data points is equal to 1568.45. All right, so the So the sample mean, remember the sample mean is the sum of the data points divided by the n. So this implies that the sample mean x bar, which is this divided by n, okay, is gonna be equal to 52.2817. Okay, so this is the sample mean. All right, the next thing we need to find is the sample variance. Remember the formula for the sample variance. I'm going to use the unbiased version. I mean, the unbiased version has an n-1 in the bottom. Okay, and this you can write as, I think I showed you in one of my lectures before the break. I showed you that this you can write another formula for the sample variance is the following. Okay, this is another formula for sample variance. Now, using the stuff that you're given, you can compute this as, because n is 30 and minus 1 is 29. The sum of xi squared is given as this 83006.73 minus n is 30 multiplied by x bar squared is 52.2817 squared. Okay. Now, if you do the math for this, you will get the following. You get 34.67. So that's your sample variance. Okay, guys. All right. Now let's look at the first part of the question. The first part, you are told that sigma squared, the population variance, is 30. So in other words, we are assuming that the population variance is known. All right. So the confidence interval for the mean, you should remember from my lectures way back, you know, the confidence interval for the mean in this case is given by this formula. Yeah, this is the formula for the confidence interval, right? In the case that the population variance is known, right? So this becomes x bar, we know, is 52.2817. Alpha is 0.05 because we are looking for 90%, sorry, 95%. So alpha by 2 will be alpha by 2 will be what? Will be 0.025, so it will be 975. Okay, and sigma is the square root of 30, and n is also 30, by the way, so they do cancel out. All right, now you should read this from the table for the normal distribution, which I gave you a long time ago. You may recall that I gave you the table well before the Easter break. So if you read that off the table, you will get 1.96. Right. So this is the confidence interval for the population mean, and the variance is unknown. Okay. All right. So that's part one. Part two is this. Part two, we are assuming that the variance is unknown, right? So sigma squared is unknown. So in this case, the formula for the confidence interval for mean is this one. All right, this is the formula for the confidence interval for the mean. Right, so once again, x bar is equal to 52.281 plus or minus t n minus 1 is going to be 29. 1 minus alpha by 2 is 0.975. S we already computed. S is 34.67. And n is 30. So it's square root of 30. Right? Okay, guys. So you should put it. You should read this from the T table, which again I gave you long before the Easter break. I gave you the copy of the T table, right? Oh, you have a question. Somebody has a question. Oh yeah, you are right. Sir. You are right. Thank you. It's S squared. So I should take a square root. Yeah, you are right. I should do a square root here. Thank you for pointing that out. I make some stupid mistakes sometimes. I mean, so if you read this off the table for the T table, you will get 2.045, all right, multiplied by 34.67 divided by this, right? Okay, so this is the confidence interval that you will get for the population mean when the population variance is unknown, right? And you're also asked to, another question from question number 2 is also asking you to find the confidence interval for sigma squared. Now, you may recall so this is the CI for, let me write it down. So what I have written here is the CI for, it's a CI, the confidence interval for mu. Mu is the population mean. All right, now we want to find the confidence interval for sigma squared, which is the population variance. Now, you may recall from, once again, from stuff I did before the Easter break, this formula here is all, all these formulas are in my handwritten notes, and they are also in the printed notes. So either of the two notes you should be able to see. All right, so this is the confidence interval for population variance. Okay, so to work that out, we're gonna, again, I'm gonna sub in the numbers. N minus 1 is 29. S squared is, we just worked out S squared, which is 34.67, I think. Correct? Yeah, it is, yeah, 34.67. And divided by chi squared, n minus 1 is 29, alpha is 0.975. So this is 29 multiplied by 34.67 divided by chi squared, 29, 0.025. Okay, now to read these values, you need the chi-square table, which again I gave you well before the Easter break. I gave you a copy of the chi-square table, right? Don't tell me you don't have it. Okay, so if you read it off the table, this is what you get. You get 29 multiplied by 34.67 divided by 45.722. Okay, and here you have 29 multiplied by 34.67. Excuse me, my writing is getting bad and bad every day. Sorry, cancel. This should read 34.67 here. 34.67 divided by 16.047. Okay. So these two values, I just write them off the table for the chi-square distribution. You should have a copy of the table. I gave it to you. I gave it to you on the first day of classes. So if you look at the stuff I gave you, you should see it. All right. So this is the confidence interval for sigma squared. Okay. All right, guys. So we're done with question 2. Now, can we move to, unless you have questions? This is okay with you, all of you, or no? Unless you have questions, can we move to question number 3, please? Oh, man. If you have a question, please use the chat box. Right, let me stop this and so share screen, share. All right, so this is question number 3 is here over here. So it says you have 500 households, 80 of them have 3 or more TV sets. Find an approximate 90% confidence interval for the proportion of households having 3 or more TV sets. Yeah, I'll give you like 2 minutes. Guys, you okay? Are you doing question 3 now? Mm. I mean, in addition to these live sessions, you can also see the podcast from last year. I mean, the podcast from last year, I mean, I already posted them online in the course website. And I think I sent you guys, I sent an email to all of you saying where you can see the podcasts from last year. I gave you the link, I think. So on top of what I'm doing right now, you can also watch the podcasts from last year. Okay. All right, guys. So let me show you, if you haven't done it yet, let me show you how to do question 3. Okay. So stop share and share screen. Microsoft. Okay, here we are. Okay, so this is question number 3. So let okay, let P denote the proportion of households having 3 or more TV sets. Okay. Right. So we want to find the confidence interval for P, and we are told that n is equal to 500. Right. And out of that, 80 of them have 3 or more TV sets. So the sample proportion, remember X bar is the sample proportion. The sample proportion is going to be the number of people that have TV, or the number of people that have 3 or more TV sets divided by the total number, which is 500. Okay. So that's your sample proportion. So 80 divided by 500 is 0.16. Okay, so that's your X bar. All right, and we are looking for is it 90%? Yeah, we are looking for a 90% confidence interval. So your 100 times 1 minus alpha is 0.9. So your alpha is 0.1. Okay, so if you look at the scan notes before the Easter break, or the printed notes, you will see the formula for population proportion is something like this. It's X bar plus or minus Z 1 minus alpha by 2, X bar 1 minus X bar divided by N. Okay, so this is the formula for the confidence interval for population proportion. You will see this in the scan notes and also in the printed notes. Okay, so this is going to be 0.16 plus or minus Z. Alpha is 0.1, so it's going to be 0.95. X bar, which is 0.16, multiplied by 1 minus 0.16 divided by 500. Okay, so this is the formula you get. Now, if you read this off the table in the normal table, right? This is what you get. You will get 0.16 plus or minus 1.645. Okay, multiplied by 0.16 times 0.84 divided by 500. Okay, so this is the answer to question number 3. Any questions? Please talk to me, guys. Don't be afraid to talk to me. All right, so this is the answer to question number 3. Okay, any questions, guys? All right, are you okay with this? All right, can we go to the next one, which is next question? Let's see. Okay, let's skip question 4. Can we go to question 5, please? Question 5. Question 5 on sheet 9. So can you please look at question 5, please? So let me stop this for a while. Share screen. Question 5. All right. Can you have a look at it for a couple of minutes? All right, guys, so I'm running out of time. So let me show you how to do question 5, okay? So here we have, we are assuming that sigma is known, and we are looking for the confidence interval for mean, right? Mean reaction time. Not so we are looking for, all right, let me Let me show you how to do it. So this is question number 5. All right, so we are assuming that sigma is equal to assuming that sigma is equal to 0.05. All right. Okay, this is the confidence interval. So the confidence interval for the mean when the sigma is known, as I already mentioned earlier today, is this is the confidence interval for mean when you know the value for sigma. Okay. All right. Now the width of the confidence interval is the difference between the upper limit and the lower limit, right? So it's gonna be 2. So you should take the difference between the upper limit of this interval and the lower limit of this interval. You get this, right? Okay, and this is equal to 2. Sigma is already given to us as 0.05. Okay. So this is going to be equal to 0.1 multiplied by this and divided by square root of n. Okay. So this is the width of the confidence, and we want the width of the confidence interval not to exceed 0.02. So we want this to be less than or equal to 0.02, right? So which is the same as saying that, it's less than or equal to 0.2, okay? And this is the same as saying that 1 over root of n must be less than or equal to 0.2 divided by this, okay? And this is the same as saying that n must be greater than or equal to the square of this. Okay. All right, guys, so that's the value for n. All right, now let's answer the question. The first part, we are assuming that we want a 95% confidence interval. So in other words, we want 100 times 1 minus alpha to be 95, which implies, of course, that alpha must be 0.05. All right, so n must be greater than or equal to 0.975 divided by 0.2 powers 2, right? So in other words, this is the same as saying that n, if you read this off the table of the normal distribution, I'm sure all of you know how to do it. It's gonna be 0.975. If you read it, I think is that right? 1.96 is that right? I mean, yeah, I think it's 1.96. Excuse me. So it's gonna be 1.96 divided by 0.2 squared. So this is the answer for part 1 of question 5. Okay, and for part 2 of question 5, we are taking 100 times 1 minus alpha to be 99, right? Which implies that alpha must be 99 I said, right? 99. So 99, not 90. So this must be 0.01, right? So n is greater than or equal to 0.99, z 0.99 divided by 0.2 power 2. All right. So in other words, n, this is the same as saying that n greater than or equal to 2.58 divided by 0.2. Okay. So that completes question number 5, unless you have questions, unless you want to ask me something. All right, so that's that. Are you okay with that, guys, or not? Are you okay with question 5? Yes, no? Okay, all right, guys, so that's it for today. I think we really run out of time today. So I mean, the remaining questions, you can find the solutions online. I mean, you can find the solutions on the course website. I have recorded this session, so you can view it. If you want to view this one more time or many more times, you can see it later on. So I will upload my video, and I will also upload the written notes, right, later on today, as soon as I can, so you can see it again later. All right. Okay, guys, everything okay with you guys? Have a good day, and of course you can contact me. You can contact me. It's 24 hours. I mean, wherever you are, 24/7. You can contact me any problems you have. Right? Just stay safe. Okay. Stay safe wherever you are. Okay. Have a good time.